T is time. It will take value of 1 for the first observation, for second it will become 2, and for 3 it will become 3, and so on. T is the time.
The T in the power shows that we are accumulating the time period.
Yes, when T is coming into the power, this means that for the first observation, your variance is 1, rho power 1 into 2. For the second observation, it is 2 into 2. For the third observation, it is 3 into 2, and so on. Rho power 3 into T. Okay, so yes, please.
So basically, this the rho should be between 0 less than rho is less than or equals to 1.
There are two options. Rho could be between any, it could be less than 1, or it could be equal to 1. The third possibility is rho greater than 1, which is excluded because if rho is greater than 1, this will increase very fastly, and the real economic time series do not increase at such a fast pace. Okay. So now let me come back to tell you why the unit root testing is so important, why we are putting so emphasis on this, and what are the misunderstandings related to this. So for 5 minutes I will ask to turn off the multimedia, please. 5 मिनट के लिए इसको फिर बंद कर दें. So there are two possibilities for an economic time series. If you have xt, this could be stationary, or it could be unit root. Okay. When it will be stationary, if you have the series like this, xt is equal to rho xt minus 1 plus epsilon t, and rho is less than 1, absolute value of rho is less than 1, then this is stationary. And if you have rho is equal to 1, then this is unit root. Okay. If I put rho equal to 1, the series will be like this: xt is equal to x t minus 1 plus epsilon t, right? And if I extend this, I can write xt minus 2 plus epsilon t minus 1 plus epsilon t. And then I can further extend, it will become xt minus 3 plus epsilon t minus 2 plus epsilon t minus 1 plus epsilon t. And in this way, I can expand this series to the origin. So ultimately, I will get x1 plus epsilon 1 plus epsilon 2 plus up to so on, epsilon n t. This is your xt. What is happening in this series? It is sum of all the past information, with every information carrying weight 1. The coefficient of every past shock is 1. So it is integrating, it is basically integrating all the past information. So this is called integrated series. This is also termed as integrated series. right? Now, look, if I have this series and I'm making an operation xt minus xt minus 1, I have shifted the xt minus 1 to left hand side, and on this side I have only epsilon t, and epsilon t is already, we have discussed, this is white noise, right? So this is del xt and this is epsilon t, which is white noise, and the white noise is also stationary. Right? So this is why this kind of series is termed as difference stationary. Why? Because I take first difference, it will become a stationary. If I take first difference, it will become stationary. So that's why it is termed as difference stationary. And sometimes this is called
The last equation it is x1 of the independent side.
xt, x1, yes, x1. Okay, so this is sometimes termed as I1, which means integrated of order 1. What is integrated of order 1? If you take first difference, it will become stationary. If you take first difference, it will become stationary. So that's why this is called I1. If you can design a process in which you need to take two differences to make stationary, then it will be I2.
That I2, is it possible to take once and then take another one?
Yes.
Or take two strips?
No, the differencing should be like this. For example, you have xt minus xt minus 1. This is first time differencing, del xt. Now, you will take second differencing, del square xt is equal to del xt minus del xt minus 1. It's not like this, xt minus xt minus 2. This is not second difference. Okay. The first difference is del kind of series, and then you take difference of this thing. This will become second difference.
Sir, when we take second difference to make the series to series, is it good to take second difference, for example, normally people report only up to first difference all level. They don't report second level.
Look, we have one possibility here. As I have said, you have this kind of process. If rho is greater than 1, it will become explosive, right? And you are not considering the explosive series to be matching with real economic time series. So this is out of possibilities. In a similar way, you can design the I2 series, but I2 series also behave in explosive way. I2 series behaves in explosive way. It increases at a very fast pace. So it is said that real economic time series cannot behave like the explosive.
Theoretically, second difference is not possible.
Not plausible.
Up to we can
You can take 0 difference or 1 difference, that's it. Right. So you have many names for this series in which the coefficient is 1. You have this integrated series, and you are terming this as difference stationary. And you also label this as I1. So how many names are there? So far 3. But there are other names as well. One of those names is random walk. What is random walk? This is a concept borrowed from physics. Basically, you might have listened to this word when you were studying physics in your matriculation. The motion of molecules of water is Brownian motion, yeah, random walk, that kind of things. This is, yes, this is same random walk. If you are standing at this step, you don't know what the next step would be. Would it be in this direction or in this direction? This is random walk. And this is basically driven from the word drunkard random walk. When someone drinks, he does not know where to go, and next step would be unpredictable. So this was a word basically driven from that phenomena. But then in order to civilize this, the word drunkard was removed. So this is now random walk. Okay. On the other hand,